So hello people, so today we'll be solving LeetCode daily question 201, that is a bitwise and of numbers range, and in this we'll be given two integers left and right that represent the range from left to right, and we have to return the bitwise and of all numbers in this range inclusive. Okay, so for example, let's say we are having left equal to 5 and right equal to 7, so its bitwise and will be 4, and left equal to 0, its bitwise and will be 0, left equal to 1, right equal to the 2 to the power 31 minus 1, this would be this. Okay, and its output would be 0. So okay, so first if I'll just show you that if I just try to do the okay, so if I'll just try to show you that, let's say if I'm having answer equal to left, and then while my left is less than or equal to right, what I'll do answer and equal to left, and then I'll just do left plus plus, and at the end I'll try to return answer. It will give me a TLE. Okay, so for the base test case it will get accepted, but let me okay, so it gave me TLE here only. I guess I made a mistakes or something. Oh, okay, sorry, while left is less than, yeah, I guess that this should work. Let me just yeah, I guess I'm so bad at implementation. Okay, so I guess instead of initializing it with left, I should initialize with the maximum value. And now if I'll just run it, I guess it will still give me TLE only. Yeah, and it gives me TLE for like such a basic test cases. So I can't just think that it will get accepted in a huge test case like left equal to 1. And for such small ranges like left equal to 5 and right equal to 7, it's giving me TLE for this only. So I can't expect my answer to be like in this way, that I will just do AND of all numbers. But for this I will like to show you a beautiful the pattern which we can see, or an observation which we can see is that, for example, if we are having left is equal to 5 and my right is equal to 7. So first what we can check is that if both of these numbers can be represented by equal number of bits. Okay, like for example 5 can be represented as 101, and 7 can be represented as 111. Okay, 1 1 yeah, and okay, so there's the spacing issue. Okay. Yeah, I hope that it will be easy to understand that. For example, 5 can be represented as 101, 7 can be represented as 111. So we need to we need to make the AND of all the numbers. For example, in this range, that is 5 and 7, and also 6 will be included in this range. Let's add 6 also, and 6 can be represented as uh, sorry, yeah, 1 1 and then 0. Okay, so what we can notice is that we can represent all the numbers that are from the range left to right can be represented with the same number of bits. Like if for representing this, we just need 3 bits. For representing 6, we need 3 bits, and for representing 7, we need 3 bits. Okay, so because leading zeros don't matter a lot, so just that's the thing. And what we can do is, if I'll just try to some do a AND for 5 and 6, it will give me okay, I'll just write and it will give me like 1 1, it will surely give me a 1. For 1 0 it will be 0, and for 0 1 again it will be 0. Okay, and now if I'll just do this and with this 7, and if I do and so yeah, it will again give me I'm at the stage, yeah, it will give me 1, and here 0, and here again 0, because 0 and 1 comes is out to be 0, and 0 1 0, and only 1 1 gives me answer as 1. Okay, so if I'll just check the answer here, the answer is also 4. Okay, and in the rest this is one of the observations, but what we can see is, if we are having, let's say, left is equal to 5 and my right is equal to 8, sorry, 8. Yeah. If we are having this, so this is not possible to represent 5 and 8 will be definitely be represented by different number of bits. For 5 I need just 101, But for 8, I need an extra place like 1 0 0 0. This is the binary representation of 8, whereas this is the binary representation of 5. Okay, so if I'll do a range and of for from like 5 6 7 8, I'll be always my answer will always return to me 0. So first thing is that what I can check is that the number of bits needing required to represent the left and right are same or not. If they are not same, then definitely the answer would be 0, because if I'll just show you that, let me just copy this, that how 6 is represented. Okay. Yeah. And let's add a leading 0 here also. 0 1 0, and let's just do it for the 7 also. That 7 is represented as 0 1 1 and 1. Let's align this a little bit. Yeah, so if I'll just do, I know that the and for 5 and 6 will result me with the of and will result me with uh like it 0 and 0 will again give me 0, and 1 and 1 will give me 1 1 0 0 and 1. And if I'll do other and here again, that and it will again give me 0 1 0 and then again 0. And if I'll try to do this and with this, I'll do and here, and here I'll be getting all zeros 0 0 0, because the number of bits required to uh, true for the binary representation of a certain number is more than the number of bits required to represent the number that is present on the right, that is on the right range. Okay, so for example, if we are having this range, so in this we'll definitely getting our answer as 0 1 2, any of the possible answers. But if the number of bits required to represent the left range and right range are different, we are definitely getting a 0. This is for a every test case, and it's just simple observation, because if we are having, let's say, if the range is from my left from 8 to 15, then there will be definitely an answer. But the moment it gets 8 to 16, I'll be having one extra bit, and then all the bits will be set to 0, and at that moment my all the remaining bits will be 0, no matter how much big the number is. Okay, so this is one of the observation. Another observation is that we just need to find the long common prefix we are having. For example, in this case, I have represented it in 32-bit decimal binary representation, that is 4 4 4, and each of them having 4 bits. So now the longest common prefix is our answer, that is this in this case 5. Let me just change the color to green. Okay, the whole text color got changed. I'll just set it back to black. Yeah. If I'm just having this much, we can see, okay, let's just leave the leading zeros also. This is the common prefix, and for this is the common prefix we are having. So that's why our answer came out to be 4. And also I've shown you above that our answer is 4 in this case. And I'll just write that this means this is equal to 4. And yeah, so this is we have also calculated that our answer is 4. For example, if we are having range 6 and 7, then also we need to find the longest common prefix, that is again 0 1 1 from here to here, and also here also. Okay, but for example 3, which is that 1 and 2 to the power 31 minus 1, we are having this as the common prefix, that is just this 0 and this 0, nothing else. So the output came out to be 0. Okay. So these are the two major observations that we need to make. And now let's just dive into the coding part of for this. And this is just the worst solution that you can ever think of, the that is currently written on the screen. And okay, so what we'll be doing is we'll be setting that left will be equal to right, and we'll be just simply calculating the number of shifts we have to make. Okay, so for, let's say, my currently shifts are 0. And now what we'll be having is that while my left is less than right, what I'll be doing is I'll be moving my left to write by 1 bit, and also by, write my right range to the right. I'll be moving one like a right shift operation by 1 bit, and I'll be just increasing the shift. And after this, what I'll be doing is I'll be returning my left, and I'll be moving it left. I'll be doing performing a left shift operation on this by the shift number of times, and that will return me the longest common prefix that is possible. Okay, so now let's just run it. Okay, shifts. Oh, sorry, shifts, and here also shifts. Now let's just run it. Oh yeah, and it gets executed. Now let's submit it. And works perfectly fine. Okay, so I'll just show you a quick dry run for this also, that the code which I have written. For example, we are having the range I was having is 5 and 7, 5 to 7. My 5 is represented as 101. My 7 is represented as 111, and my while left is less than right. For the first iteration, what I'll be having is my after my first iteration, my 5 will become 0 1 0, because I made one left shift operation. This is my 5, and then in 7, for 7 it will be like 0 1 1. Still there, my left is 4, and here my left is 3. Okay, so notice this thing, that here my left has become sorry 2 now, and my 7 is 3. So again, my left is less than right. So what again I'll be doing is I'll be in this my second iteration, I'll be moving again 5 by 1 bit. It will now turn to 0 0 1, and my 7 will also turn to 0 1 and 1. Okay, so sorry, 0 0 and then 1. Okay, so this is the and now at this point my left is not less than right, so it will break, and total number of shifts done that are 2. So now if I'll just move 5 by 2 bits, 5 left shift by 2 bits, so that will give me 0 1 0 and then again 0. Because if you just okay, so sorry, not this 5. Here I am talking about this 5. Yeah, that is 0 0 1. If it's my present data at this index, then it will go to 2 bits left, that is at here 1, and this number is my 4. This is equal to 4. And I'll just write that my here my left becomes this, and here also I'll just replace my 5 with left so as not to have any confusion. Left, and here this is about my right range. Right, yeah. So this is how at this point the loop will break, and my left will be represented as this. I'll just make left move by the 2 bits, and this will give out me the output as 4. Okay, so that's how the solution will work, and this was it for today. Thank you for watching.